fundamental derivative calculus and the definitions of a derivative. The derivative of a function f at x is defined by this expression here. We say this f prime of x is equal to the limit as delta x goes to 0 of the function f of x plus delta x minus f of x divided by delta x, provided this limit exists. That sounds a little bit complicated as we first start down the road of calculus, but we're going to break this down into its individual pieces and hopefully explain to you exactly what this represents. We recall from earlier in our mathematics graphing lines. The slope of a line is defined by usually the letter m. We use the phrase rise over run, or rise divided by run, but it's simply a difference in y divided by a difference in x. You're going to see how this concept is basically contained in the derivative. This blue line represents a function, f of x. If I look at some point here on the function, f of x, we put x into the function and it gives us f of x. We often will refer to that as y, but f of x makes a lot of sense here. If I move over some distance, delta x, remembering that delta is always referring to a difference in x, or a difference in a variable, and I take the point x plus delta x, in other words, x added to this point here, it symbolically would be x plus delta x, and bring it up to the function, that is going to define a point f of x plus delta x. If I look at these 2 points and draw a line between them, here shown in green, that line has a slope that is defined by the mathematics we've already played with. If I look at this line and think of its slope, and here's my rise, represented by that vertical distance, and my run, represented by that horizontal distance. We know via similar triangles that that same rise and run can be represented by the math we have here. And I'm going to show you how we do that now. If I take from our definition of a derivative, f prime of x, the limit as x goes to 0, f of x plus delta x minus f of x divided by delta x. All we're going to do is look at this portion right here. And we're going to determine where we get that. If I bring this over here, I can see that my rise here, my run here, can be defined in terms of the symbols that I already have. So if I were to take this and say the rise divided by the run, or the slope of this green line, is defined quite simply. The rise we can show as this dimension subtracted from this dimension. Well, that is f of x plus delta x here, and we subtract f of x. We see, if we come back to our definition of slope, that's a delta y, or a difference in y dimensions, shown right there with the math that we know. If I want to look at my run, simply delta x in this case. Delta x. So all we have defined in this expression using fancy math is a slope. That's it. Very simple concept that we understand from our previous geometry lessons. Return to our definition of a derivative, we see that there's this other piece, the limit as delta x approaches 0. And we have to try and understand how that affects our slope. Well, it's quite simple actually. If I take this delta x and reduce it, it brings this point over. I'm going to draw that now. What I've done is I've come in and actually selected a new point, a new delta x, which is smaller than our previous. Taking a new x plus delta x, bringing it up to our blue function line, and defining a new f of x plus delta x. When we draw a new line between these 2 points now, our original f of x and our new f plus delta x, you'll see that this line more closely approximates the actual slope of our function between those 2 points. As delta x continues to get smaller, this line will more closely approximate the slope of our function. And when the limit as delta x approaches 0 is this line will actually exactly define the slope of our blue function at this point. That definition is something we will use in mathematics as well as physics to understand this curve and the rate of change of this curve. So again, utilizing our simple concept of slope, which we understand from our previous math, and limits, which we understand from earlier this semester, we can understand the derivative as it stands here, which we notate as f prime of x, the small mark being the prime, is equal to the limit, as delta x goes to 0, of a slope. Things that we have all understood from previous uses in math. So the only real new math here is a new notation, f prime of x, and the vocabulary derivative, which is new to us in this class.